All right, we are on the Speaker UNPrep Terminal Challenge. This is a multi-level challenge that results in you getting into the speaker prep room, turning on the lights and turning on the vending machine, all of which result in access to further challenges, but hints as well. So definitely a good one to do for sure. And as we'll see, not terribly difficult, but the last level does get a little bit interesting. So if we head on over here, I've got a lot of windows open at this point. All right. So this is located on the floor. I don't remember. What third floor is that? Just below the rooftop, where all the talks are. And if you go to the left of kind of the whole room, you see Bushy here. And let's see. So for the first one, first step, which is getting the door open, there's not a lot that Bushy says about that, but we do get some details here. The door is controlled by this binary door, but it needs a password. If you can figure out the password, it'll open the door right up. And then it says if you have extra time, help with dot lights and also vending machines, and they have configuration files attached to them. We've copied editable versions of everything into the .lab folder in case you want to try editing or removing the config files. And this does not require low-level reverse engineering. So if we do door, because that's the first one, it says, look at the screen, it wants a password. You roll your eyes, the password is probably stored right in the binary. There's got to be a tool for this. So this is a classic, secret is stored in plain text in the binary. And just because it is a binary and not like a text file doesn't mean that we can't search through that binary. A great tool, which a lot of you probably have heard of, is called strings. And strings basically looks through any sort of file that you give it, doesn't matter what it is. It'll look through a binary just as much as it would look through a text document. It's going to try and find and identify printable, screen printable groups of characters, I guess also known as strings, and it will print them out. Now, if you've ever looked at a binary file in like a hex editor, you'll notice that, a lot of the file, you'll see those like dots in the ASCII printing area, and those just represent a sort of byte that is not printable. It's not within like the ASCII, ASCII chart, if you will. But there are sometimes, and they're either actual valid strings or they're just happen to be, a binary section that was a printable string. But anyway, so if we're looking for secrets and somebody has written this binary to just store, variables that aren't encrypted or anything, we can pull things out like that. So for this one, I'm not even going to try entering a password. I'll simply run strings on the binary. And just so you know what the output looks like, we get a lot. We see some of the different sections of the file here, of the binary, like the .data.bss, and we get some information about the actual binary. You can always run file against a specific, what is this, door? File door. Yeah, so this is a ELF binary 64-bit. So we see some details about that binary layout and stuff like that in here. But we can do strings and then we can pipe it into grep to search for a specific keyword. And we're looking for a password. So I'll grep for password and boom, there we go. The password is open the door. So I'll go ahead and just copy that. And then we'll run /door. And when prompted, we'll enter the password. And boom, door open. So that'll give you some sort of unlock, which will unlock the door, and you can go inside now. But we're going to do the other two challenges right now. So next step is lights. Lights has a configuration file. Okay, so it looks like we have some sort of potentially encrypted password there, and then elf-technician as name. So this is that configuration file. Also, as mentioned before, inside of the lab directory, we have copies of these, which we can go ahead and modify for testing purposes. And yeah, so if we run, let's just go ahead and run lights, because that's the next step. We can see some text here. So how do you turn the lights on? If only there was some kind of hint, and then that gets interrupted by configuration file loaded. Select fields decrypted. Welcome back, Elf Technician. Okay, so I believe Bushy might have given a hint about this. Let's see, I'm trying to see if I can read that. Not really. I guess he only gave one for the ending part. But what I'll say here is we looked at this configuration file. Oops. Lights.conf, please. Can't type. So we looked at this configuration file, and the Elf Technician, obviously that's not encrypted. The password, however, looks like it's encrypted. Now, the program is telling us that there are select files decrypted. So I'm wondering if we can put this potentially encrypted password in the name field and actually edit the configuration file and see if it'll decrypt the password for us. But first things first, let's just verify that that's not actually the password. I screwed that up. And it's not. So let's go ahead and just try to modify this lights.conf to see if my suspicion is right. So we'll remove Elf Technician and put the password in there and run lights again. And there we go. Welcome back. Not Elf Technician, computer-turn lights on. That looks like a password to me. So we'll take this and we'll get out of the lab directory and we'll run it against the production binary /lights to execute that. And we'll go ahead and enter that in there. Boom, lights on. So that would solve that part. At this point, you could talk to Bushy and he would give you some hints for the final challenge, which involve deleting or renaming the config file and running the binary, setting the password to 8 A's or 8 B's. If the encryption is simple codebook or rotation ciphers, you'll be able to roll back the original password. Perfect. So you might have seen my tab up here about polyalphabetic ciphers. I will get to that in just a second, but let's take a look at vending machines. So this is the final challenge for this, or final level for this challenge. So it says loading configuration file from vendingmachines.json. I wonder what would happen if it couldn't find its config file. Okay, and it's asking us for some sort of code. All right, so invalid password. So let's go into lab where we can modify stuff. And let's simply move vendingmachines.json to vendingmachines.back. That way, the binary, when it goes to look for the JSON file, it does not find it. And let's go ahead and run that program and see what happens. All right, alert, configuration file is missing. New configuration file creator activated. Please enter the name. What, test.json? Please enter the password. Oh, I see, okay. So that creates, it creates a vending machines.json. Okay, let's try that again, .json. This is what happens when you record solution videos like a month after you do the challenge. All right, so enter the name, Dan. Enter the password. So let's do, it's suggested to set the password to 8A. So 1, 2, 3, 4, 5, 6, 7, 8. Not sure if that matters yet, but we'll do that. And we don't know the password, so we'll just Control-C out of that. Okay, so now let's look at the contents of vendingmachines.json to see what we get here. Okay, so it looks like it is running our given password through some sort of encryption algorithm and spitting out whatever that is. Now, we had 8 A's, I believe, and we have 1, 2, 3, 4, 5, 6, 7, exactly 8 in our encrypted password. Okay, let's go ahead and move this to JSON A. Oops. JSON I'm just going to move that file and let's run this again with B's now, just to see what's going on here. So 1, 2, 3, 4, 5, 6, 7, 8 B's. And let's cat vending machines.json. Okay, so now we get exactly 1, 2, 3, 4, 5, 6, 7, 8 different characters. So let's try with, so let's just get rid of all those. Oh, I did not want to do that. I meant to get rid of the JSON files. That's fine, we'll just do that. All right, so let's try this again. Enter the name Dan. So let's try a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because it's talking about some sort of a rotation cipher. So I want to see what this, if, you know what, actually, I'll do you one better. Let's see if we can identify some sort of repeating pattern. So let's just feed it a ton of A's for now. We don't know that. All right, vendingmachines.json. All right, cool. Looks like we have a pattern here. So 1, 2, 3, 4, 5, 6. I can't count. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like every 8 characters, it's repeating. Okay, so this is where polyalphabetic ciphers come in. All right, so what is a polyalphabetic cipher? It's a cipher based on substitution concept, which uses multiple substitution alphabets. Yeah, so we look at this kind of table. Requires 2 inputs from the end user, plain text and key value. Easy to implement. It's used in these ciphers. Okay. So I only learned basically after this that it was a polyalphabetic cipher, but I just wanted to kind of give you an idea of what we're looking at here. Let's see if there's a better explanation somewhere here. Multiple substitution alphabets. Veneer cipher, okay. Simplified special case. Enigma machine. Oh, this looks like a cool site. So we've got this ciphertext here from our password. Yeah, so this is essentially what we're looking at. We've got our plain text alphabet, and then we've got our ciphertext alphabet. So we are mapping, basically shifting how the alphabet's working. And as we can see from our output, not only is it shifting it, but it's also, it's got like a pattern to it. So, you know, if you're just looking at an 8-character window, it's going to be different for each character, but that pattern repeats, and that is what allows us to break it quite easily. So I'm going to bring in some completed work already, just to expedite this process, but I want to show you how I eventually solved it. How do I... There we go. All right, so let's drag this over. All right, so you can see I did that kind of 4-character repeating, or 8-character repeating pattern, and extracted exactly for each value, for each letter of the alphabet, what the corresponding encryption value was. And I did a test, you know, every character ended up being that, like, within that 8-character window, that pattern repeated. So that was for the entire alphabet. So what I did here is I simply built out a, you know, a polyalphabetic kind of decryption chart. So we know it's 8 characters. So I just lined these all up, lined them all up all the way. So we've got our capital letters, lowercase letters, and I even did 0 to 9 for our numbers. And so all I did was I generated, oh, that's for later on. Okay, I generated a very long password that was 8 A's, 8 B's, 8 C's, 8 D's, 8 E's, 8 F's, uppercase, and then I did all the lowercase ones. And I did 0 to 9, and I just had one very long password. And what I did is I copied the resulting encrypted password from the JSON file. I brought it into this spreadsheet, and I just, every 8 characters, I hit enter, 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 so that they were each on their own line, okay? And then I matched them up with their corresponding, alphanumeric character. So at this point, we can now take the encrypted value that is in the production vending machine's configuration file, and we can basically begin to decipher this polyalphabetic ciphertext. So this is the actual encrypted password from that configuration file. So we've got uppercase LVE, lowercase d, and so on. Okay, so we've got 10 characters there. That is 2 more, obviously, than 8. So that means that at character 9, we're going to have to roll back to the beginning of our pattern. Okay, so let me kind of just walk through one by one how this works. So we've got capital L. What we're going to do is in this row, with all these 8 characters, we're going to look at the first index, or I guess 0 index, what has a capital L. So we can, and this is manual. My buddy wrote a script that was like a few lines of Python that just did this automatically for him. But for me, I prefer to do these manually, just to really drive it home. So, all right, first one, we see the first index is L, capital L, and that corresponds to C. Okay, so that's the first. I know it's kind of giving it away, but that's the first character of our decrypted text. Next one, we're going to look for V. Okay, so now we're not going to look in this first column anymore down the line. We're going to look in the second one. So we're going to look for a capital V. So I'll just do a Control F. That might help us find it a bit quicker. So capital V. Here we go. So A. And then we're just going to keep continuing down the line. So now we've got capital E. And we're going to look in the third index. So 1, 2, 3. I should probably get my 0 and 1 base index down. But we're going to look in the third column here for a capital V. Do a little search on V. Or E, sorry, E. That's what I meant. E is here. So that's N. Okay. Next is lowercase d. So in the fourth column here, I can make it a little bit bigger. In the fourth column, which is this column here and down, I also made it courier near series monospace, so these lined up somewhat. We are looking for lowercase d in the fourth column. That's here. So we have, that actually corresponds to D, so that's kind of funny. Okay, so you can see how we're building this out. Now, we get to 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these last 2 characters, this is where it gets a bit interesting. We know this pattern repeats after 8 characters. So now we need to take it back to the beginning of the pattern and start looking again at that first index. Because if we don't, well, we'll actually just run out of stuff to look at. So it just rolls back, back to the beginning of the pattern. So now E, we're going to look in this first column again, just like we were doing before. The pattern's now restarting. So lowercase, excuse me, I actually meant W here because this is the ciphertext. So we're going to look for lowercase w in the first column here. And I must have missed it. Here we go. So now we get E, and that matches up. And then finally, lowercase r for the second column, which is right here, and that is 1. So then we pull this out and we get candy cane in camel case and 1, and that is probably our password. So if we run the production vending machines with candy cane, boom, vending machines enabled, and now you have solved all levels for the Speaker UNPrep challenge. If you have any questions, let me know in the comments. Be happy to help, and we'll see you in the next video.